Am I audible to everyone? Excellent. So, welcome to this 5-day course on what you see on the board. Yeah, sustainable manufacturing technologies. We'll talk mostly about additive and about coatings. Yeah, and of course there are ways to combine both, which then becomes hybrid. Yeah, and we'll also have some talk on subtractive, but that's what we are trying to avoid, right, when you do additive. But there is some merit in hybridizing that way as well. Uh, I just now heard that some people are still on the way, their trains are delayed or some such thing, yeah. But we will start in any case, right? And I want this to be different from a normal course, correct? Uh, it is very rare that I stay on a campus for 5 days. I have never done that in my life in the last 15, 20 years. Yeah, it's great. And all of you also are staying on campus, right? So feel free. Uh, I will, uh, in a minute, put up my email ID, take my email ID and say, okay, I want to meet you at 6 o'clock today, and then we will try and meet, right? If you have any questions. Because it's very hard to do a course where there are BTech students, masters and PhD students and faculty, right? So there is a risk that whatever I say make some people unhappy, correct? You may say, oh, this is too high funda or this is too low funda or whatever, right? So I will try and correct that by meeting with you wherever I can, and then my ambition also is that I manage to be a resource for you. Later on, if you find something that you would like to know, you should just send me an email, even if I'm not here. If some of you PhD students are looking for samples, I hope I can send you some samples. Not everyone, and not all kinds of samples, but some. If I can support at least one or two of you, I'll be very happy. With some faculty, I will be delighted if I'm able to set up some sort of a collaboration. So I have an ambition which is larger than just a 5-day course, right? I want this to sustain. But first, let's talk about the course, how we are going to do this, right? So the main course faculty are the three of us here, right? So I will do most of the talking, unfortunately for you. But both Dr. Venugopal and Dr. Manjia will help with some courses. And I'm extremely delighted that we've been able to convince Deepa, who I've known for a long time. And this was intentionally done. We wanted to give you some industrial perspective, not just academic guys talking for 5 days, right? That's boring. So we wanted to give you an industrial perspective, and that's why I think we couldn't find two better people than these here. Deepa has a long background from GE R&D, from Pratt and Whitney after that, and her move to Ramaya is only recent, but she's mainly an industry person, not an academic. And Santosh, I've never met Santosh, but I've heard good things about him. He's from Hexagon, and I think he's a valuable addition to uh, the kind of coverage we want in this course. Okay? So that's my email ID. If you want to set up a time to meet me sometime, yeah, that's my email ID. So take that down, use it in the next 5 days, use it beyond this course, but yeah, just feel free. That's what is important. Let's see how the schedule looks like. I'm a little bit confused here by this schedule. I wasn't aware of the inaugural, but we will find a way. I was going to talk a little bit about a short introduction. Fortunately, it's short, so I'll make up time there. Yeah, talk about introduction to sustainable manufacturing, and then directly get into metal AM, what processes are available. But Dr. Manjia, we largely stick to this, right? Yeah. So if I have time up to 1:15, I should finish these two. Is that correct? Yeah. Okay. Right. Then that is day one. first of all, some of you may be very disappointed that the other course has a book, and what the hell, you guys have not given us anything, right? But the title is Sustainable Manufacturing. So we want to be sustainable, right? We don't want to print books, yeah? So, as Dr. Venugopal said, you will get a QR code. There's everything there. Even what you don't want to see is also there. Yeah, so there's plenty of stuff there. Don't worry about that. So day 2 tomorrow, we will talk a little bit about feedstock for metal AM, and then we will have Dr. Manja speak about sustainability in producing some of this feedstock powders, and yeah. And then later tomorrow afternoon, I'm going to talk about a very important aspect related to AM, which is post-treatment. Yeah, why do we do post-treatment? How do we do post-treatment? What is the motivation for that? Let's talk about that. Day 3, so let me show this. Yeah, this is better. So day 3, it's a pleasure to have Professor Venugopal start off, right? And then that's when I begin to speak a little bit about surface engineering. So the way I will cover it is standalone. Yeah, I'm not going to at this point begin to combine surface engineering with AM, but I'll talk about surface engineering in general. An important part of this course is also the lab sessions in the afternoon. You will have it on most days, maybe not all days. For example, today you don't have a lab session, but on most other days you will have something happening in the lab. On day 4, we will wrap up with surface engineering. Surface engineering is such a vast field, right? Just like AM is, and it's older, so it's become even bigger. So there is a limit to what can be covered. But I hope I give you a good idea that as a designer, what a wide toolbox you have when it comes to surface engineering, what many different things you can do, right? And then we talk about design for AM. Santosh will do that, and then also an important related aspect is numerical simulation. Dr. Manja will cover that, and day 5 is when Deepa comes in and talks about 2 very important aspects. One is industrial qualification. Sometimes industrial qualification is very challenging, right? You build a part, but to actually use it, you need qualification, especially in key sectors like gas turbine, whether you're talking about aero engine gas turbine or even land-based. You need qualification, and then Deepa has some experience with that. And the other aspect is repair, right? That is a key anchor in sustainability, to reuse or remanufacture parts, right? So we thought that too is important, right? And some little bit of hybrid I'm going to postpone till this part, right? So I'll talk about AM separately, surface engineering separately, but talk about combining these 2 here, because I think that is where the future research focus can be, especially for the faculty who are out there. I think that's a good area in which you can pitch your grant applications and ask for money, right? So we will postpone it until that time, right? So busy 5 days, but as I said, if it goes too fast or too slow, just stop me and catch me at other times, perhaps. What I have done is I have taken the liberty wherever possible to seek out expertise that is available around me, right? So if you take something like sustainability, it's a fairly new field. People have different imagination of sustainability. It means different things to different guys, right? So I have taken help from my colleague, Klaus Fredrickson, who is part-time at our university. He's part-time at Cambridge, and he also works a little bit on making a software that gives you data related to sustainability and that kind of stuff, right? So this to me is a very fuzzy field, right? Uh, just to get to know you guys better, how many of you are BTech students here? Yeah, BTech students. How many of you are PGs here? And how many of you are faculty? Some faculty. Okay. So let's start with BTech. Yeah, any one of you BTech students, right? What is your understanding of sustainability? What is sustainability for you? Any one BTech student? Way of living. Very good. Yeah. Uh, we will lose too much time to ask others if they agree with you or not. But all right, way of living, nice. Postgraduate guys out there, PGs, you're thinking of sustainability. Any one opinion? Come on, UG guys have said, so pressure is on you. Yeah. Excellent. That's also good. Yeah. And faculty, then. Way of living, attending to our own needs without kind of taking over needs of the future generations. That's also nice. Faculty, anyone? Even more pressure. We have UGs who have answered, PGs who have answered, now faculty.
Processing of the raw materials to create the products by keeping the environment in the priority.
Excellent, right? So we have 3 points of view. As we go along, we will see if any of them is correct, all of them are correct, or whatever, right? But thanks for your input. So here is a definition of sustainability from the UN. Meeting the needs of the present without compromising the ability of future generations to meet their own needs. Good job. So PG is winning so far. Yeah. So that's the definition from the UN, right? Seems simple and seems very close to what she said, but I'm not sure if she understood everything she said. Yeah, because this is a very deep statement in one sense, right? It's easy to write, but to actually practice or implement is very tough, right? And we will, in this short introduction, we'll try and get there eventually, right? So where is the starting point, right? So this is the definition, same thing that I showed you just now, which dates back to 1987. Oops, my thing is going different, right? So the starting point is here, yeah? This is okay to say, but how do you accomplish that, right? Because if we look around ourselves, it's a very complex ecosystem, correct? We have the planet and something that you said comes into play there. Yeah, how do you get raw materials or make products without harming the environment, right? You know, people, and both of you kind of spoke about people, and then there is business, correct? Which at least till recently had a single-minded focus. They wanted to make money, correct? They still want to make money, correct? So this is very, very complicated. How do you find some region like this, which takes care of everybody's ambitions, right? And still ensures that whatever we do is sustainable, correct? So that is what we are going to talk about. Not so much, but just to set the stage for, it's important for everyone to know. So this is now almost a mandatory course in our undergraduate program also on sustainability, just so that people have heard of it, right? Whether you practice or practice it or not is little bit up to you, but I think everyone should practice it, correct? So you need to, whenever you're talking about sustainability, you inevitably need to take care of all three. You have to take care of the natural capital, you have to take care of the human or social capital. You must worry about ensuring that industries also survive, right? They can't take care of both of these and incur a loss, right? Then we are in deep trouble, correct? So all these three need to happen, and that is where we have a challenge. Why is that a challenge? What do these arrows mean? I mean, I must admit that this picture is from the internet, of course, Google Maharaj, yeah. But what do these arrows mean to you? They mean something to me. What do they mean to you? To me, they mean that all these three things are pulling in different directions, right? So there is pressure in entirely different directions when you talk about planet or humans as a race and their ambitions and the desire for the industry to make profit. All of them pull in different directions, and that's where it becomes very complex, right? So it's important to know that. Let's understand a little bit about all of these three capitals. What do we mean by the natural capital? Atmosphere, land, fresh water, ocean, this and that, right? And that ties in very well with what he said, correct? You must make sure that whatever we do, this is never compromised, right? Are we doing that at the moment? Are we taking care that this is not compromised? No. By no means are we doing that, right? Let's look at the financial capital. You're looking at GDP and everything related to that, right? So, and you talk about human and social capital, simple ambitions, right? Doesn't matter where on earth you live, right? The ambition is the same. People want access to education, health, they need to be empowered by knowledge and skill, and they just want to be happy, right? Not breathe air and fall sick. No, you don't want to do that, correct? So these are the three capitals that you must always take care of when you talk about sustainability, and that's the challenge, correct? So let's understand what these three pillars mean. Yeah, environment, you must ensure that natural resources are consumed in a smart way, yeah, and they are renewable. And this pillar almost always seeks to maintain ecological integrity and about protection of the ecosystem, right? By being responsible in how you consume resources, right? And that's the reason why there is increasing emphasis on on renewable sources of energy, right? You may consume, but they should be renewable. They should be replenished, correct? Economic, yeah. I think there is more and more reason to ensure that don't worry about tomorrow. Worry about long-term economic growth, right? You don't want to do something that gets you money for the next 2 or 3 years, but makes all of us almost bankrupt in different ways, not just economically, over a long period of time. So this usually ensures that human communities have access to required resources to meet their needs without compromising future generations, of course, right? And social, we just spoke about that. This is simple. The ambitions are not very high, but this is what is impacted the most, unfortunately. For all the sins that others commit, the biggest casualty is the social pillar, right? If you see what's happening in Delhi, for example, right now, right? You don't want that kind of a situation, right? Fortunately, there is now an evolving concept of sustainability. It's not what we used to think earlier, right? So my earlier cartoon showed this. So this is a very narrow-minded way of thinking, right? As opposed to that, we are transitioning from what people like to call this intersecting mode of sustainability to an integrated mode of sustainability. What does this mean? What does this imply? That above everything else, you must take care of environment, right? Next comes social equity, etc. Social. And in the end, right, once you tick off these two boxes, you worry about profit and economy, right? So, this is what is called the integrated model, right, which recognizes that your foremost responsibility is towards the environment, yeah, and social well-being of not just US of A, yeah, let's make America great again, no, not like that, yeah, whole environment, that's important, yeah, and because if you take care of these two, hopefully this follows, right, and I don't know if it's in my next slide or later, but fortunately the industry is also beginning to understand that, at least worldwide. There may still be very narrow-minded businessmen, but industry by and large understand that. So, I don't think I will answer all of these questions when we speak, but all of you, when you are taking a shower or lying in bed, instead of seeing reels, yeah, infinitely, you should think about why is sustainability important? Is there anything we can do, each one of us? Is there anything we can do? Like not printing course notes, that's one of the things, yeah. And how can we do different things in life that make it better? Not for everyone else, for your children, for your grandchildren. Let's just think about them, right? And then everything is okay. If you think you're doing it for someone who's living in Congo or Zimbabwe, then you don't think like that. About our kids, right? Then thinking is different. Because until now, we have always been thinking about economic development. When I say we, I talk about industry, right? Because that's where it comes from. We have been thinking only about economic development, climate change, resource depletion, etc. Let it go to hell. We don't care. There are some leaders of the world who do not even believe in climate change, correct? Dangerous, correct? So, it's a well-documented fact. For example, if you look at greenhouse gases and related emissions, that more than 90% comes from extraction of resources, our own resources of Earth. And the way it is impacting us is in ways unbelievable, unimagined. Yeah, all of you come from different parts of India, I think. Have you seen climate change there in wherever you live? Or are you seeing it? Have you seen it change? Yeah? I remember as a kid, I used to spend every summer in Pune. And at that time, we used to think Pune is a hill station, right? Never remember as a child, needed not a blanket, but something to pull over in peak summer as well. Today, impossible, yeah? Touches 40 very casually, correct? So, it is real. You look at parts of the world getting snow in summer, right? Or parts of the world not seeing snow at all, where there used to be mountains of snow, correct? So, it is real. And for that, the UN, in its own wisdom, has set an agenda for sustainable development. Their goal is 2030, you know, but unfortunately, UN is very toothless, right? They can make plans, they cannot implement anything, right? But however, it is very educative to see the dimension of the sustainable development. How many things they talk about? Yeah, we only think about renewable energy and say, oh, but there are so many dimensions of sustainable development which are identified by the UN, right? For us, no time to go into all of those, but it will be available when you scan the QR code, right? Maybe, or maybe I forgot to add this slide, I don't know, but you should look this up, that's important. And statistics may lie, data never lies, in my opinion, correct? Data is always real. So this is data of how temperature has gone up over time, yeah, especially from around 1950, 1960. Is this a big deal? Yeah. Someone may say, oh, 1 degree से क्या होता है life में? Correct? बहुत कुछ होता है. I mean, many things can happen, right? Snow can melt like nobody's business just because of 1 degree. Lot of things can happen, right? So remember this. Around 1950, 1960, we have started behaving in not a good way with the earth. Yeah. So that is not your fault, because I think all of you except me were born way after that, right? So the disease began during my time, but all of you are also involved now in this game, correct? So almost more than 1 degree difference, right? And I doubt very much personally if it will follow a linear slope. I somehow think this slope is going to change, right? This slope is going to change, right? And that means hell. How have we abused everything? Again, real data, population. Look at how it has gone from about 1950 onwards, right? So it is not a coincidence that you see all this data and look at what has happened to temperature, correct? Or global warming and greenhouse gases and stuff like that. Look at population, look at GDP, yeah, or your desire to make this go up. Look at primary energy use. Look at it along look at tourism, right? 1950 onwards is unreal. Yeah, people want to travel like crazy, which is not bad, but you must find a good way to travel, correct? Everybody driving a car is not okay. Yeah, if you can avoid it, public transport, if you can. But then the responsibility is also on local governments to provide access to public transport. I cannot say take public transport and there be no public transport available for miles together, right? So we are therefore tackling a huge problem, correct? And not one single person or one single government can solve it. But I'm going to give you an example of how the Swedish government is doing, because that's where I come from, right? So in 2006, now almost 20 years ago, there was a Swedish law that all universities should promote sustainable development in their education, right? At least people should understand what sustainability means, what its dimensions are, and all the universities in Sweden do that already, right? And they've been pretty ambitious. Whether you reach those goals or not is a different matter, right? But the bar is high, right? You don't want to be a world-renowned high jumper and put the bar there, right? Where I can just go like that. No. You need to put the bar high. And the bar is very high, that by year 2025, there will be no greenhouse emissions, right? Will they reach that? I can almost guarantee that they will not reach that, right? But no problem in having the bar high. And there is also, because of such laws, and especially the young generation getting involved, yeah, through what we do in universities, there is huge public opinion around global warming and what governments can do or what industries can do and cannot do, right? Which is nice, right? So I will not get into details, but some points to note that the Climate Act of Sweden kind of tries to ensure that nobody will interfere with the climate system, right? Protect it. And there is, of course, resentment among the public many times, because the public then asks, why should we be the only people who should pay for the world's problems? Is the rest of the world doing that, right? And those are the kind of challenges. If the population starts getting inconvenienced and say nobody is doing it, but I'm paying a price, yeah, then they change very quick, correct? And for that reason, it's important that all countries do something similar, right? to the extent that they can. So let's see what the climate targets have been. When this was signed in 2008 or whenever, the ambition was that the emissions should decrease. I told you no emissions by 2045, but should decrease by 40% by 2020, 63. I mean, these are all documented in the law, right? 100% in 45 means 85% reduction and 15 by way of compensation, right? Like you do something, you plant trees, you return the carbon credit sort of, right? Where are they now? 29% compared to 1990 level. Target was 40. What do you think about 29%? Yeah? Will you criticize that, oh, you are barely 75% of the target? Will you criticize that? Or will you say that 29% is pretty impressive to reduce from 1990? And I think 29% happens because the bar is at 40%, which is unrealistic, but the bar is high, correct? So they may not get anywhere near that, but let's say by 2045 they are at 50%. Not bad. At least some tangible difference is happening, correct? So I don't want to go too much into this, maybe child and cause problems, right? And therefore, extremely important that we keep this in mind, right? All of them show this crazy trend at about the same time, right? So enough about that, yeah? Please think about this, at least on a weekend, or but do think about it. Let's look then at traditional manufacturing, yeah? This is how it has happened, yeah? Take resources via mining or whatever, right? Make the raw material that you need out of that, right? Use it to fabricate products that give you joy and luxury, or sometimes it could even be necessity, I don't know, yeah? So take, make, use, and then junk it, dispose it, right? Is this sustainable? No way, yeah? You cannot sustain it. And that's the reason now you will see all the buzzwords, but they're really not buzzwords, right? What are some of the buzzwords related? Circular economy, yeah? Recycle, reuse, correct? All of this you will hear more and more of, right? But that is important, correct? When we now talk about manufacturing and sustainability, it needs again to take care of the same three pillars, right? The manufacturing also should ensure that you are doing it in an environmentally benign way, yeah? Still provide the public with what they need, and take care of economic aspect as well, so that industries thrive and survive, right? So, if you want to do it in a sustainable way, you can look at probably reuse, remanufacture, repurpose of raw materials, look at reducing manufacturing cost, look at energy consumption, right? I'm not getting into detail, but you can see that slowly we are coming towards additive manufacturing somehow, right? In a strange sort of way, right? You want to be able to have the design freedom so that you can make your parts lighter. You want to reduce wastage, right? So all of this is slowly pointing towards the merits of additive manufacturing, right? And that's the reason I thought I should spend some time. Yeah, so essentially different ways of saying the same thing, right? But important for us to manufacture sustainably, right? And do keep track of that. According to me, the nicest thing that is happening right now is that companies are beginning to realize that there is substantial financial and environmental benefit that results from sustainable practices. Yeah? Environmental benefit, I think companies always knew that if I do something in a right way, there is environmental benefit, but maybe I don't care about it. That used to be how they thought. But now they realize that there is also financial benefit. How many of you have taken flights recently or booked flights? Many of you? Yeah? How many of you have seen your flights when you book indicate what is the carbon footprint for the flight? How many of you have seen that? Anybody seen that when you're booking there is carbon footprint? Yeah, I'm traveling from Gothenburg to Frankfurt, Frankfurt to Hyderabad. What is the carbon footprint, right? They mention the carbon footprint. Some companies, and that's where the financial part comes in, they also make you, or not mandatory, but they ask you, would you like to pay a certain amount, yeah, to pay for use what you are contributing to the carbon footprint because of your travel, right? Little bit, correct? So you see suddenly that change happening around you, right? So which is, I think, a positive sign, yeah. Almost all of them now realize that it's also a saleable thing, right? One of our biggest projects, we will get to that maybe when I talk about coatings, is for instance, to find an alternative to cobalt, right? So we have a large project from one of the biggest powder manufacturers in the world, Höganäs, which is a Swedish company, and they're giving us lots of money to see if we can make as good coatings, but not use cobalt. If you look at wear coatings today, the most popular coating is tungsten carbide cobalt, right? So the first goalpost for us is to avoid using cobalt, yeah, because that has many sustainability implications. Cobalt is on the list of EU's critical raw materials. So is tungsten actually, right? So so that is step 2, because it is harder to replace. Cobalt is slightly easier to replace, correct? So you do that. And for that reason, I think it's nice that companies begin to think differently about sustainability, and many of them, at least the big ones, now consider that all of these are a part of their corporate social responsibility, which is nice, no? They think that they should not just look at the financial bottom line, but also consider both social and environmental performance of how they produce things, how they recycle things, and suddenly for that reason, people are beginning to wonder about batteries, for example, right? How do you recycle? Where does the lithium go, right? You're using so much lithium for your batteries. Where would it go eventually? Once the batteries reach their end of life, what happens to them, right? So a lot of emphasis on things like that, which is important. So if we are going to count on our fingers, what should we prioritize when it comes to sustainable manufacturing, or what are the main benefits? Lower resource and production cost. Lower resource is obvious. Lower production cost not so obvious, yeah. But that's something we need to keep our eyes on. Lower regulatory compliance laws. There are more and more regulations coming out now, which will insist that what goes into your product is sustainable. Otherwise, the penalties would be heavy. And it's important that the penalties are heavy, or something like hard chrome. People have complained or legislated that we should not use hard chrome for a long time, but is it implemented? Not yet, not in many countries, right? So that's there, yeah, and yeah, various other things. So that's important. And as I said, the most refreshing for me is how the companies approach sustainability. Companies of all sizes today, right? That leads to improved, not just resource footprint, but also in many ways better performance. And then, yeah, and that is what is spurring innovation. The reason we get research funding is to a large part driven by the fact that these companies want to become sustainable, right? Uh, we are at the moment spending a lot of effort, at least on these 3 R's, right? Being able to recycle, right? I'm just showing cars here, but it's only an illustration. But in all product life cycle kind of issues, we are trying to see if we can recycle at end of life, whether we can reuse, right? Or we can somehow recondition by taking it back to where it started, right? In some way. There's a lot of emphasis on that, right? Some examples of how it links to manufacturing. Light weighting, right? That's a big plus from additive, or to go from steels or super alloys towards aluminum, magnesium alloys. What's the big deal with lightweighting? Why would you want to lightweight? Yeah, why would you want to lightweight? Reduce it? Almost correct. Energy use, efficiency, you said something? Reduce cost, yeah, little bit, yeah. So it's different things for different applications, right? If you're building the same part out of the same material, yeah, but using less material, I mean, that way of lightweighting is one thing, right? Using lightweighting so that your emissions are lower, like in gas turbines, that's another reason for lightweighting. But all of those eventually, this is nothing new. I'm just listing it out here for you. But we can do all of these things with or without additive manufacturing, let me say, right? But additive manufacturing is an important cog in the wheel, so to speak, right? So if we can do, we can use additive manufacturing, you can, easy to imagine that through appropriate design, this part is easy to tick off, yeah? If you do coatings, this part is easy to tick off, right? This is related to those two, so that's easy to tick off. So many of these automatically happen because of additive manufacturing and because of using coatings to extend life and therefore not having to replace parts so frequently, right? So that happens, by the way. Now this is something which is an enabler for additive manufacturing in particular, right? Doesn't matter where you start, better performance of products, right? I mean, if you take a turbine blade with very intricate cooling holes, it used to be a nightmare earlier, right? You make a turbine blade out of supposedly the hardest, one of the hardest materials, like nickel-based super alloys, and then drill a hole through that. Not easy, right? But now you can build it into that. So much better performance in that sense and functionality, right? Very simplified manufacturing. You can imagine the trouble in machining of super alloys, right? Extremely hard, can do that. And then reduced costs, of course, apart from the fact that you are saving so much material, right? By using a bottom-up approach rather than a top-down approach, right? I thought this is something I must put up, right? For a moment, imagine that you are not reading the rest of the text. Is additive manufacturing sustainable always? I think this is crucial. It depends, right? It's not always, so you cannot close your eyes and say, okay, I'm making this lid today in some way, tomorrow I'll start additively manufacturing that. No, it's not always sustainable. It has potential to offer sustainability by doing these things, right? But the manner in which you produce could be consuming more energy, right? So there's a flip side to it. You may use less material, you may make your parts lighter, but you may be consuming lot more energy in accomplishing these two, right? And then it's not okay, right? And therefore, you should not be fooled by someone who says that everything you can additively manufacture. Doesn't work like that, yeah? And for that reason, this is crucial, right? You must be very clear where a certain component or a certain component that you are now able to design in a particular way because AM is available, and you know that I won't have to machine it like I used to traditionally do, and therefore it opens itself to new ideas of design. Yeah. So if you do that, then maybe there is a lot of benefit to be had. But if you don't do that, it doesn't automatically mean that what you're doing is sustainable. It could be quite the contrary, right? So that is why we have one of the talks from an invited guest speaker focusing on design for AM. Yeah, this is a big field at the moment, right? So he will speak for an hour and a half. I don't know if that's enough, right? But you must all know that this is crucial, right? In some cases, AM makes a lot of sense. In some cases, it may make no sense at all. And that's one of the things you must remember. There is always a tendency, especially on part of researchers, right, or academic guys like me, to say that whatever I do is the best, right? That's not true. If I work on AM, AM is not always the best. If I work on thermal spray, it's not always the best coating technology, right? In some cases it would be, in some cases it won't be, right? So as a designer, it's up to you to make that judgment in a good way, right? So be sure about that. Since we are covering both AM and coatings, I also wanted to quickly touch upon how a coating technique. I'm taking just thermal spray as an example because I have mostly done thermal spray in my life. I like it. I like how versatile it is. But what can it do? It can reduce emissions in operation by, for example, allowing you to operate a turbine at a higher temperature. If you do that, you automatically reduce emissions. And one way of doing that is putting on thermal barrier coating. It can extend component durability. How do you do that? By putting on coatings which are wear resistant or corrosion resistant or resistant to whatever makes a component fail prematurely in real operation. Yeah? It can reduce material usage as a direct consequence of this. Right? If you extend life, you have less shutdowns, you throw less of your components, and therefore you reduce material usage. You can lightweight, right? If you want a certain functional property, right? For example, you are using some material today because it is highly corrosion resistant. Yeah, you don't need to make the whole component out of that material. Now there is better appreciation that you can use something else underneath if you have the ability to put on a good corrosion resistant cover around it in the form of a coating, right? Usage of environmental friendly materials. I was talking about replacing cobalt, but there are many other such issues where coatings allow you to do that. Many things. Repair is a big thing, especially for materials that are not well endowed in Mother Nature, right? So you can, it's important to be able to repair rather than junk, right? So this was my very short overview on sustainability and how it relates to manufacturing, whether it's AM or coatings. This is a huge field. My only request and ambition would be that you guys think about it, right? There are for each technology there is a sustainability angle to it, right? So do think about it, and be agile and well read, yeah, rather than believing everyone, including me, right? You should do your homework when it comes to matters like this. Any questions? Or, yeah.
What is your take on the carbon tax that Europe is implementing on India? We need to produce mass production like steel or something else.
Yeah, I mean, it's a very complicated question. Neither I can answer it nor you can answer it, right? Uh, you can choose to stay away, but this is everyone's game, right? But you're asking me the same kind of question that my colleagues in Sweden ask. Yeah, why should we be forced to go into electric vehicles and this and that, and why should, because of Sweden putting uh, a law saying that by 19 whatever that date was, 2050 or 2045, we will be emission free. Why should we pay for it? Yeah. And environment is not something like, okay, if Sweden does that, then what Denmark does, India does, rest of Europe does, doesn't bother. Sweden is safe. No, it's not like that. It's a global thing, right? So, and you're absolutely right in the sense that there are local compulsions, right? And that is why it is challenging. If everything was local and the benefits were also local, then it won't be such a problem. But the benefits are global, so the price has to be globally paid, yeah, and that's why it doesn't have an easy answer, unfortunately. Maybe you become a Prime Minister of India someday and answer that question.
Second question about cobalt. Most of the cobalt is controlled by China. Supply chain of cobalt is controlled by China. So what is your take on that? Like, Europe wants to get away from cobalt because of that.
Hey, don't ask me militant kind of questions, but what does control by China mean? Do you know where cobalt comes from in the first place? Where?
Republic of Congo, Africa.
Correct. 70% of cobalt comes from Congo, right? So forget about control and stuff, etc. It's just about dependence, right? If I am even any manufacturer, and you are the only guy selling raw material to me, I don't like that. Yeah, I don't care if it is China, Africa, or even India itself. But if you are the only producer of that raw material in India, I don't like that, because I open myself to blackmail tomorrow. Suppose you sit there and say, oh, Joshi Saab, आपको तो मैं ये बेचूंगा नहीं, right? What do I do? Or if you suddenly say, from tomorrow morning, because 26th of November is a good date, auspicious date, I'm doubling the price of my raw material. What will I do? Yeah, so it is.
EV is controlled by China. Cobalt production is controlled by China.
Yeah.
Because of geopolitical issues, what will Europe do if they want to?
Yeah, they will do what they are doing now, which is to find alternatives to cobalt. That's the way out, right? But you're raising good points, and to some extent, they also motivate what we should be doing, rather than asking these questions, right? Yeah, if Europe is imposing tax on India for carbon, what alternative does India have? Can it say that, no, we will not pay tax, we will not have anything to do with Europe? Can it say that?
It is already developing. India is developing. So there is some change.
You meet me over lunch, we will discuss more. Yeah? Anybody else? Yeah? But think about it, that's important.
Sir, moving towards electrical vehicles, does it really reduce the carbon footprint?
On the face of it, yes. But then people are slowly realizing other issues. Maybe it reduces carbon footprint to the extent of driving your vehicle, right? Going from place A to place B, not using gasoline, using, yeah, it reduces the carbon footprint. But what about other issues? Extracting lithium, disposing lithium, right? What is the cost attached to that? And I think nobody has a good answer. Suddenly it is hitting them in the face, and we need to do something about that.
Sir, producing the electricity somewhere.
Yeah, correct.
Require the
Yeah,
same,
right.
will also emit the same carbon
Absolutely correct. Yeah. So this is very complicated, and therefore it's also very multidisciplinary. Yeah. We as a manufacturing person should not pretend that we know everything, right? And that's why I wanted to, in an additive manufacturing course, wanted to make that point that additive manufacturing is not always sustainable, right? I mean, and we should not pretend that it is, right? So, hmm? but thank you for listening.